Hello, welcome to all my dear students. Today's my lecture is Introduction to Data Structure. So, the first topic of your syllabus, that is Introduction to Data Structure. So, data structure can be defined as the group of data elements which provides an efficient way of storing and organizing the data in the computer so that can be used efficiently. Data structures are widely used in almost every aspect of computer science. For example, it is used in operating system, compiler design, artificial intelligence, graphics, and etc. So what is the need of data structure? Why we use data structure? Data structures are the main part of computer science algorithms. It enables the programmers to handle the data in an efficient way. It plays a vital role in enhancing the performance of the software or a program, as the main function of the software is to store and to retrieve the data as fast as possible. So what are the advantages of data structures? The first advantage is efficiency. Efficiency of a program depends upon the choice of a data structure. For that, we take one example. Suppose we have some data and we need to perform the search operation for a particular record. In that case, if we organize the data in an array, means if we use the array data structure for that, we will have to search sequentially element by element. Hence, using array, it is not efficient for that. So, we can there are better data structure which can make the search process efficient way, that is binary search tree or hash tables. Then second advantage is reusability. Data structures are reusable. That is, once we have implemented a particular data structure, we can use it at any other place. Then the third advantage is abstraction. Data structure is specified by the ADT, which provides a level of abstraction. Means program uses the data structure without getting into the implementation details. Then next we see the data structure classification. So data structure is classified into two types. First one is called as a primitive data structure and second one is called as a non-primitive data structure. So non-primitive data structure can be classified into first one is linear, second one is non-linear. Again, linear is classified into static and dynamic. The example of static is array and example of dynamic is linked list, stack and queue. Non-linear data structure is classified into tree and graph. So first we will see the linear data structure. A data structure is called as a linear if all of its elements are arranged in the linear order. Means in linear data structure, the elements are stored in non-hierarchical way. Each element has the successors and predecessors except the first and last element. The types of linear data structure, first one is a array. So everybody knows the array. An array is a collection of similar type of data items and each data item is called as an element of the array. The data type of element may be character, int, float or double. The element of array share the same variable name but each one carries a different index number known as a subscript. The array can be one-dimensional, two-dimensional or multi-dimensional. The example of array, that is the individual element of the array age, are age 0, age 1, age 2 and so on. Then the next example of linear data structure, that is a linked list. So linked list is a linear data structure which is used to maintain a list in the memory. It can be seen as the collection of the nodes stored at non-contiguous memory locations. Each node of the list contains a pointer to its adjacent node. So here in the given figure, each block is called as a node, and the node consists of two fields. First one is called as a data and second one is called as a next. Then the node are interconnected to each other. The first is called as a head and the last node, that is called as a null. Means here no node is connected. So the link, that is the last node, is connected to the null. Then the next data structure, linear data structure, that is stack. Stack is a linear data structure in which insertion and deletions takes place at one end. That end is called as a top. It is named as a stack because it behaves like a real world stack, for example, piles of plates or deck of cards, etc. Representation of stack. Here the stack is represented by using array, and we perform the push and pop operation in the stack. A real life example of the stack, that is stack of books, stack of plates, then wearing and removing bangles. Queue. Queue is a linear list in which elements can be inserted only at one end, that is called as a rear, and deleted only at the other end, that is called as a front. It is an abstract data structure similar to stack. Queue is opened at both ends, therefore it follows first in first out methodology for storing the data items. The example of queue, that is students standing in the queue. Then the next is a nonlinear data structure. This data structure does not form a sequence, that is, each atom or element is connected with two or more other items in a nonlinear arrangement. The data elements are not arranged in a sequential structure. The example of nonlinear data structure is first is called as a tree. Trees are multi-level data structure with a hierarchical relationship among its elements that are called as a nodes. The bottommost node in the hierarchy are called as a leaf node and the topmost node is called as a root node. See the figure of structure of tree. So A is a topmost node and it is called as a root, and the last node, that is G, is called as a leaf node. Here H is also called as a leaf node. Then the next data structure, that is graph. Graph can be defined as the pictorial representation of the sets of elements represented by vertices and connected by the links that are called as the edges. So here this A, C are called as the vertices, and B, the connecting edge, that is called as a link, connected link, that is called as a edge. Then the operations of the data structure. The first operation of the data structure, that is insertion. So what is meant by insertion? Insertion can be defined as the process of adding the elements to the data structure at any location. If the size of data structure is n, then we can only insert n-1 data elements into it. For example, here we have to insert the element 35 at the index position 2. So we can insert the element at the index position 2. So such operation is called as a insertion. Second one is deletion. The process of removing an element from the data structure is called deletion. We can delete an element from the data structure at any random location. For example, delete element from an array. Here we have to delete the element 10 from the array. So original list and delete element 10. Then the new list 2, 4, 1, 7. So 10 is deleted from the list. Such operation is called as a deletion. Then the next operation, that is called as a searching. The process of finding the location of an element within the data structure is called searching. There are two algorithms to perform searching, that is called as a linear search and binary search. In the figure, we have to search the element 20 in the given array. So by using linear search, we can find the element 20 at the position number 6. So such process is called as a, to find the element in the given list is called as a searching. Then sorting. The process of arranging the data structure in a specific order is known as sorting. There are many algorithms that can be used to perform sort, such as insertion sort, selection sort, bubble sort, and so on. So here the list before sorting and after using the algorithm, we can sort the list and the list after sorting. Then the next operation, that is called as a merging. When two lists A and B of size m and n respectively of similar types of element that are joined to produce the third list, that is list C of size m plus n, then the process is called as merging. Merging means to joining the two lists. Thank you and happy learning. मला चांगलं एवढं काही नाही झालं.